The physics of electricity is in 3 segments. Segment 10 answers the introductory question, what is electricity? Segment 11 is on outlets and circuits in your home and answers the question, why do electric outlets look like little surprised faces? And Segment 12 covers batteries and the electromagnetic spectrum. Now, it's pretty obvious that the entire civilized world is technically addicted to electricity. Just going to your tap for clean water. Now there's something you take for granted. No electricity, no water pumps, no water. No electricity, no water pumps, and no wastewater removal. I suspect that outside of calling an electric lightning bolt and an electric lamp by the same word, electric, most of us are pretty clueless as to what this stuff, electricity, really is. Before we even had the word electricity, people saw this and could occasionally do this, and every now and then they would get one of these. But for nearly all of human history, we had no idea that these 3 events were connected. And it was Benjamin Franklin, one of the signers of the Declaration of Independence, that proved that these 3 events were in fact connected. By Franklin's time, people were already starting to use the word electricity to describe this weird force that attracted stuff to glass and to amber. Amber is made from the old hardened resin from certain trees. They make jewelry out of it. They would rub their amber jewelry against fur, and it would develop the inexplicable power to attract hair or small feathers. Not knowing what to call this mystery force, they took the Greek word for their amber jewelry, electron, and named this entertaining oddity amber force, or electricity, the force of amber. For centuries, people, including Franklin, would conduct the following 2 amber experiments all the time. The first experiment, they would rub amber or even a glass rod with fur or silk, which produced the magic amber force. Then, by placing the rod near a very lightweight ball made from a spongy plant called pith, the pith balls would attract or repel each other. The other experiment was just like it, using a device they called an electroscope. Instead of pith balls, they used 2 very thin sheets of gold leaf or thin metal hanging from a metal in the box. Just like the pith balls, when amber or the rubbed rod touched the top metal piece, the 2 foil pieces separated from each other. Franklin decided that there were 2 amber forces at work here. Having no idea what they really were, he arbitrarily called one of the forces positive, the other one he arbitrarily called negative. 2 negatives repel, and 1 positive and 1 negative attract. Franklin was also responsible for proving that what was happening with the pith balls and what was happening with the static shock was the exact same thing that happened in a lightning bolt. The proof was Benjamin Franklin's famous flying a kite in a thunderstorm story. Did it really happen? Well, probably. And briefly, here's what we know. originally published an idea of bringing lightning down to a rod, then touching it to see if you got a spark off of it. He called it the Philadelphia experiment, and he never did it himself. He later heard that others in Europe read his article and tried it. Some were successful. Some were electrocuted. But Franklin thought of a better idea. Instead of waiting for the lightning to come down to you, you fly a kite up into the lightning. He published another article declaring success with the kite earlier that summer. Here is the actual article, and yes, back then many of their letter S's looked like the letter F. Make a small cross of 2 light strips of cedar, the arms so long as to reach to the 4 corners of a large, thin silk handkerchief when extended. Tie the corners of the handkerchief to the extremities of the cross so that you have the body of a kite, which, being properly accommodated with a tail, loop, and string, will rise in the air like those made of paper. But this being of silk is fitter to bear the wet and wind of a thunder gust without tearing. To the top of the upright stick of the cross is to be fixed a very sharp-pointed wire, rising a foot or more above the wood. To the end of the twine, next the hand, is to be tied a silk ribbon, and where the twine and the silk join, a key may be fastened. This kite is to be raised when a thunder gust appears to be coming on, and the person who holds the string must stand within a door or a window or some other cover, so that the silk ribbon may not be wet, and care must be taken that the twine does not touch the frame of the door or window. As soon as any of the thunder clouds come over the kite, the pointed wire will draw the electric fire from them, and the kite, with all of the twine, will be electrified, and the loose filaments of the twine will stand out every way and be attracted by an approaching finger. And when the rain has wet the kite and twine so that it can conduct the electric fire freely, you will find it stream out plentifully from the key on the approach of your knuckle. But notice that Franklin never exactly tells who it is that did the experiment, which has irritated historians ever since. But 15 years later, the famous scientist Joseph Priestley steps into the story. He was a friend of Benjamin Franklin's, and Priestley wrote about the kite experiment in his book, The History and Present State of Electricity, with Original Experiments. In it, Priestley emphatically states that it was indeed Franklin who conducted the kite experiment. The air was charged enough to cause the strings at the bottom to separate from each other. It was the old pithball and electroscope experiments all over again. Notice that the kite was never directly hit by lightning, which almost certainly would have killed Franklin and his son who was with him conducting the experiment. But the heavy electric charge in the air was enough to prove that this, and this were all electrical in nature. Now, the most obvious question is, what is this charge stuff? Stay with me because this gets a little weird. Charge is a foundational component of the universe itself. And what do we mean by foundational component? A foundational component is something that we cannot define any further or break down any further. Kind of like time is a foundational component, and so are the dimensions of width and length and breadth. These are foundational components of the universe itself. Like we said in the section on fire, energy has been wound into the universe by a spoken decree, and now it is slowly and methodically unwinding, making work happen. Charge is almost certainly a part of that spoken decree. Notice this is a philosophical explanation of what charge is. So far, we have absolutely no scientific explanation for why charge exists at all, or why like charges repel and why opposites attract. As a result, we are unable to describe any further what they are, and we are left to describe only what they do. This copper wire is made of copper atoms. The copper atoms are made of positive and negative charge, so this entire wire is made of electricity. Now, you can't make electricity. The electricity was created in the beginning in the form of charge. Negatively charged electrons and positively charged protons. What you can do is move electricity. You can move the charges. If the copper atom is made of negative electrons and positive protons, that means the very essence of the atom is by its nature electrical. That means this wire is electric by nature. There isn't electricity in the wire. The wire is made of electric charge. In fact, everything is made of electric charge because everything is made of atoms from the periodic table. And atoms are made of negative electric electrons and positive electric protons. But if everything is made of charge, then why don't you get shocked when you touch things? Well, because most things are made of a balance of charges. An equal number of negative electrons and an equal number of positive protons. The result, like this stick, is balance. And when you're in balance, nothing moves. Very similar to this kinetic toy. It's balanced, neither positive nor negative, and as a result, no work gets done. The trick to getting work done in the universe is to put energy into it and move things out of balance. You take energy from one place and move it to another so it is out of balance. That way, something can happen. By putting work into the kinetic art toy, it became out of balance, and now something is happening. Work is getting done. Charge is like that. When you take it out of balance, work can get done. A lightning bolt is the shifting of negative electric charges. An area of the sky is out of balance with the charge at the ground below it, or in adjacent clouds. When the difference is great enough, a bolt of charge races through the air, balancing out the difference. When you rub your feet along the carpet, you move negative electrons from the carpet and they build up on the outside of your skin. When you touch metal, the electrons balance themselves with a tiny lightning bolt and the world is balanced again. Since the Italian physicist Alessandro Volta was one of the pioneers of studying charge, they named this imbalance in his honor. Anytime charge gets out of balance, they call it voltage, like in Alessandro voltage. Charge balance means the world is mostly at rest again and no work is happening. Take negative charge from here and pile it over here. And you've created an unbalanced world. You've created tension, the potential to do work. You've made a difference between the charge here and the charge here. You've created Alessandro voltage. So, according to Franklin, a lightning bolt is the result of nature harmonizing unbalanced charges. Same as the static charge when you scoot your shoes on the carpet, which, by the way, tells you that the word static electricity is not static at all. In fact, static electricity requires the movement of lots and lots of negative charge. Otherwise, you'd never get a spark or a bolt. So perhaps it would give our minds a better picture to say that when you scoot your shoes on the carpet, you are unbalancing the charges in the carpet and on your skin. You are moving and piling up lots and lots of unbalanced charge. You are creating Alessandro voltage. But other than scooting your feet along the carpet, how else can we unbalance these charges? We use one of these. A voltage imbalancer, otherwise known as a generator. People think that generators make charge or electricity. They don't. Only God can make charge, and the world is full of it, positive and negative charge. Generators pump charge from one area to another. Just like a water pump doesn't make water, it merely pumps the water from here to there. Burning fuel turns the generator, and that mechanical motion can create a charge imbalance, can create voltage. Amber and fur aren't the only things that work like this. There's a whole list of things that when rubbed together create this voltage, this charge imbalance. The triboelectric series. The word tribo means rubbing. The materials on the bottom end of the series hold on to their negative charges. When they touch, the top materials tend to pass their negative charges over and imbalance the materials. They create voltage. Notice that most of the materials at the bottom of the chart are man-made things like plastics and styrofoam, and most of the items at the top are God-made things like skin and fur and hair and glass and silk. There's a few exceptions, but that's a good rule of thumb. Which is an easy way to remember how charges move on the triboelectric series. Man-made things get more negative, God-made things get more positive. Plus, the further apart they are on the series, the greater the charge imbalance you can create. Take a styrofoam cup and start rubbing it in your hands. As you rub it, the positive charge will build up in your hands because the negative charge is moving to the styrofoam cup. What you've just done is cause a voltage imbalance, which you used to call static electricity, but clearly it's not static because voltage is moving. Since negative and positive attracts, the cup moves towards your hands like a magnet. The cup also attracts little pieces of paper and feathers, just like the amber did. This is why dryer socks cling to other clothes. As they tumble, they rub, and negative charges move from one fabric to the other, unbalancing the charge in the clothes. When you pull them apart, you can hear nature trying to balance the voltage with little lightning strikes that we call static sparks. Even moving liquids will create voltage. The gas nozzle has metal on it, so it grounds the pump and your car at the same potential, no imbalance. But if you pump gas into a plastic container in the back of your truck, it becomes insulated or isolated from the truck, and static charge will build. This man did exactly that, and a static spark discharged, igniting the vapors. That's why you should place the plastic can on the ground so no voltage builds up. The triboelectric series works by transferring negative charge to other materials. But why does the balloon stick to the wall? You didn't rub the wall. Well, there is a second way that you can unbalance charges. The first was by touching. The second is by induction or influence. Look, we know the balloon is negatively charged since it is down here on the series. As you bring the negatively charged balloon close to the electrically neutral wall, the tiny charges on the very surface are repelled by the negative charge in the balloon. They move away. But at the same time, a few of the positive charges on the wall are attracted to the negative balloon, and they move a bit closer to the surface. The attraction of the dissimilar charges causes the balloon to stick to the wall, just like a magnet. This is called induction or influence, since without physically touching the object, you are inducing an imbalance to the object. You are inducing Alessandro voltage. James Wimshurst was an early English inventor who made a machine that automatically induced voltage. It's a sophisticated yet simple device that forces charges to separate as the little metal bits move past each other on these opposite rotating discs. Without using friction at all, the charges separate out, just like the balloon when it moves toward the wall. The opposite charges collect on these metal combs, and when enough imbalanced charge builds up, the voltage increases at the ends until the very air breaks down and turns into an air wire, creating a lightning bolt spark, and the negative and positive charges recombine. These devices here are called Leyden jars and can actually collect the imbalanced voltage, allowing for a larger spark. Leyden jars were invented nearly 300 years ago in Leyden, Holland. They are so simple and clever that you can make your own and store unbalanced charge in them. You can store static electricity, store voltage. Leyden jars are named for a geographic area in Holland. Depending on where you are from, it can either be pronounced Leiden or Leyden. It's kind of like this. Imagine that this is a water Leyden jar, using water instead of charge. The jar is always full of water, and there's a rubber membrane in the middle separating the two sides. Pump water in, and the rubber piece stretches. When you stop pumping water, you still have the same amount of water in the jar, but you've imbalanced it. You haven't stored more water or more charge. You've stored energy. Open the valve on the left, and the energy stored by the stretched rubber pushes out, just like a Leyden jar discharging its stored energy. Similarly, a Leyden jar doesn't store charge. It imbalances the charge. Normally, the negative charges from the charged PVC here would go immediately to ground, but the plastic or glass in the middle stops it. The positive charges on the outside are attracted to the negative charge, but the glass is in the way again. Then by connecting the inside metal to the outside metal, the charges balance and come to rest again. Another early charge separator is this machine, invented by Robert Van de Graaff in 1931. It works by friction, the same way rubbing your feet on a carpet does. Van de Graaff needed to generate high voltage for early particle accelerator work. Using the triboelectric series, this Van de Graaff uses a rubber belt rubbing against two rollers of different materials from opposite ends of the series. If I touch it with this metal sphere attached to the other end of the Van de Graaff, it balances. If I place this plume of strings on the top of it, the charge will move around each string. And now they all want to get away from each other. If I touch the strings, they balance again since I am standing on the ground. Larger Van de Graaff generators will do this to your hair also. This copper pipe is made up of gazillions of copper atoms, but they're all evenly charged, an equal number of electrons to protons, no voltage, no static buildup. The same is true with my hand. My hand is made up of charge, but it too is evenly balanced, no voltage. All the electrons and protons move together. And when electrons and protons move together, we call this motion. But if some of the negative charges begin to move while the positive charges stay still, something amazing happens. When negative charges move or drift away from their normal position around the positive protons, a field appears, a force field, an invisible energy force field that travels at the speed of light. It appears surrounding the wires wherever there is an imbalance of charge, and as the charge slowly drifts, this field quickly advances. It's an electric force field. It is this electric force field that makes your lights turn on and makes motors run. It is this energy moving at the speed of light that the electric company sells to you. They sell electric energy. When it flows through the filament of a light bulb, this electric energy field gets converted into heat and light. The positive and negative charges, however, never leave the wire, and the negative charge continues in its drift. At the same time, if the charges begin moving, another field, a magnetic field, appears at right angles alongside the energy field. This is why electricity and magnetism are so closely related. It is astonishing. Scientists have a special name for this electric and magnetic energy. They call it electromagnetic energy. Seriously. The field carries energy in a similar way that a fish creates waves of energy as it swims through the water. Since all the electrons are very close together, they move like a chain. It's a chain reaction, and the electric energy field moves at the speed of light. The electric company creates generator pumps to imbalance and move the charges, then sells you the created energy field. This energy field is what lights our cities, runs our televisions and air conditioners, our houses, and runs our cell phones and refrigerators. Electricity is, first, particles of positive and negative electric charge, and second, waves of instant electric energy. This is electricity.